Hello and welcome. My name is Bhuvan Unhelkar, and in this module we're going to discuss one of the two interaction models in UML, sequence diagram. The other model is collaboration, also known as communication diagram. But both these diagrams serve the same purpose, and that is to show what is happening in the memory of a computer when we execute our programs. So appropriately we call these diagrams as dynamic diagrams. There is another diagram, state machine diagram, which we will study a little later, which is also a dynamic diagram. So what's the difference between a static structural diagram such as a class diagram and a dynamic diagram such as a sequence diagram or a state machine diagram? Well, the class is the program. The class is containing the logic, and even the attributes and their declaration in a class is still a shell or a template. For example, we design a class customer which has attribute names like first name, last name, address, date of birth, and so on. Now each of these attributes are defining some piece of actual data. So if the customer is John, when we execute the customer class, the data that comes up in the memory, that is loaded in the computing device's cache area, is all related to John, whose customer ID might be 101. We then upload another customer, Bhuvan, whose customer ID is 305. So you see, objects are actual real instances of a customer such as John or Mary or Bhuvan, and we use the sequence diagrams to show or to investigate or to model what is done or what is to be done to that particular object when that object is loaded in the memory. So as you can see, the way in which customer John is treated, he wants to update his address, and the customer Bhuvan, who wants to make a query about the number of accounts he has. Different requirements. We had captured these requirements in its generic form in our use case documentation. We then had our flowcharts, activity diagrams, which had multiple threads. And a sequence diagram is even more specific because it's going to show what happens to each object. Now, a bank can have 10 million customers or more, and you're not going to draw 10 million sequence diagrams. So your attempt to draw a sequence diagram is to provide a visual cross-check on some of the key sequences in your system. Create a customer, modify a customer, delete a customer, modify some aspects of the customer, and so on. So in that sense, a dynamic diagram like a sequence diagram, it's never complete and it's not all inclusive. So you can have 2 or 3 or 4 or 5 sequence diagrams which can correspond to 1 or 2 activity diagrams, and of course have a much closer mapping to the class diagram. So it's not a one-to-one mapping. One sequence diagram can deal with many objects which belong to many classes, and one class can appear in multiple sequence diagrams. So in the module that I have provided to you, you will find first all the notations, the elements. Not all elements are used, but some of them are pretty necessary. You will find you can start a sequence diagram with an actor, but it is not necessary. You can always have a sequence of how you are storing a message in your database. Then no customer, no actor is involved. I have also shown you the basics where one object sends a message to another object. Patient object sends a message to doctor object. Note the terminology. These are objects. So a patient, which belongs to class patient, is sending a message at runtime in the memory to a doctor object belonging to class doctor. You can have 3 patients send a message to a doctor, A patient, B patient, C patient, which are all belonging to class patient. So our case tools help us map the objects to the classes. So the mapping of A patient colon patient, which is the class, is not to be done manually. In most case tools, when you create an object in a sequence diagram and right click on it, it will show you list of classes that you have already created in your class diagram or in the browser of your tool, and you can select the class to which this object belongs. If you can't see the class that should contain this particular object, you have missed a class. So a sequence diagram is also a nice mechanism to identify missing classes. Also note the message that goes from, in my example, patient object to doctor object. Now that message is not a typed up created message. It is an instance of the method or the function or the operation in class doctor. So in this particular example, a patient is sending a message to a doctor object, and that message is the instance of the method in doctor class. So if you imagine, or if you recollect the class that you have created with various attributes and various methods or operation or function, those methods are called by other classes. At runtime, those methods are messages that are received by the receiving class object, and that's how you will have interactions within your system. So an object on a sequence diagram belongs to a class in the class diagram. That is the first mapping. And a message on the sequence diagram belongs to a method in the class, receiving class. So keep that in mind. You will find I have given various examples using various stereotypes. The boundary stereotype, which could be an actor, which could be a interface, user interface, sends a message to a entity object which in turn sends a message to the table or database object. And then if you recollect the robustness discussion we had in the previous modules, we can insert control classes which will separate the interface or the boundary from the entity and the entity from the database or table class. Apart from that discussion and those examples, I have also shown you focus of control. Why this is not important in the model of problem space, MOPS, when we do requirements, when we do analysis, but it is important in the design space, which is the model of the solution space, where you find that you send a message and then that message spawns off a few more messages. Until all of that is complete, your sequence is not complete. For example, you send a message for logging in. I enter my user ID and password, and then from that interface, the entity class that deals with login and validation sends a few more messages at runtime. Check Bhuvan's ID, check Bhuvan's date of birth, or whatever it is. And when all of that is complete, the sequence of logging in, if successful, is complete. So the focus of control tells the programmer, the designer is telling the programmer, which is myself in both roles, that the sequence continues till the focus of control, the bar on the left, is thickened. So you will find that at design level, sequence diagram plays a very crucial role. It tells through visual expression how the sequence of messages are going to happen, who is going to send the message, who is going to receive the message, what will be the message, what will be the return value, and it can go 3D, 4D, 5D. As I mentioned, a sequence diagram shows the sequence of messages. Again, try and remember your classes. If you have a customer class with 5 methods that you have coded, one is create customer, another is change address, third is create date of birth, or whatever it is, calculate age. You can code these methods in any sequence you like in a class. You can have change address first and create a customer next. The sequence in which you code these methods in your class doesn't matter, because that is a static entity thing. But how do you want these methods to be executed? That is the responsibility of sequence diagram in design. So I would consider it as a very important diagram. I have shown creation and deletion, I have shown focus of control, I have shown mapping of sequence diagram to class diagram, and then there are a few examples which are using stereotypes. And finally, I have also reminded you of the principle of robustness through an example in a sequence diagram, because in a sequence diagram we are showing exactly how a message will be sent to a control class from an interface, which will then send a message to an entity, which will then send a message to another control class, which will then send it to the database or table class. So I hope you are getting a grasp of a sequence diagram. It is one of the 2 crucial diagrams in the solution space. The second one is the state machine diagram, which we are going to discuss in the next module. So I hope you are enjoying this study as much as I am enjoying presenting it. Take care. Bye bye.